Hello friends, in today's session we will be discussing about encoders and decoders. Encoder. An encoder is a digital circuit which converts familiar numbers or symbols into coded forms. An encoder performs the inverse operation of a decoder. An encoder has number of say m inputs, but only one out of these is activated at a given time. A encoder has number of say n output lines. We will take the example of a octal to binary encoder. An octal to binary, also known as 8 lines to 3 lines encoder, accepts 8 input lines and there are 3 output lines. The truth table of octal to binary encoder is given by the following table. We are having here 8 inputs and 3 outputs. The inputs are D0, D1, D2, D3, D4, D5, D6 and D7, while the outputs are A0, A1 and A2. Now if you will see here, in the first entry, the D1 is high while all other are low. In the second entry, the D1 is high while all the other inputs are low. And we are having the corresponding outputs 0, 0, 1. For the third entry, the D2 is high input. All other inputs are low and we are having 0, 1, 0 at the output. And similarly, for the last one, we are having D7 is high and we are having at the output 1, 1, 1 as A0, A1 and A2. The logic expression for output, we are having A0 high when D1 is high, D3 is high, D5 is high and D7 is high. So we can write A0 is equal to D1 or D3 or D5 or D7. On the same lines, we can find out for A1, it is high when D2 is high, D3 is high and D6 is high and D7 is high. Similarly, for A2, we are having high output for D4, D5, D6 and D7. The logic circuit obtained from this is very simple. We have just odd all these inputs. Here we are having D1, D2, D3, D4, D5, D6 and D7 as inputs and corresponding inputs D1, D3, D5 and D7. They are odd here to obtain output A0. The same is true for A1 and A2. The next is the priority encoder. The encoder has a limitation that only one input can be active at a given time. If two inputs are active simultaneously, the output produces an undefined combination. For example, if D3 is high and D6 is high simultaneously, the output of the encoder will be 1, 1, 1 because all three inputs will become 1, 1, 1. This does not represent either of D3 or D6. In order to overcome this limitation, we have to go for the priority encoder. The purpose of priority encoder is such that if two or more inputs are equal to 1 at the same time, the input having the highest priority will take the precedence. Let us consider a case in which there are 4 inputs D3, D2, D1 and D0. The input D3 has the highest priority, D2 has the next highest priority and D0 has the lowest priority. The truth table gives the input-output relationship between the different variables D0, D1, D2, D3 and the output variables x and y. V is the valid output indicator and is set to 1 only when one or more inputs are equal to 1. See the first entry, none of the input is high, so V is 0. Now in the next entry, D0 is high, then D1 is high, then D2 is high, and D3 is high here. So the V is having the value of 1, 1, 1 and 1. Since D3 is having the highest priority, if D3 is 1, then D0, D1 and D2, they can have any value. It may be either 0 or it may be either 1, as is indicated by the X. Similarly, if D3 is 0, D2 is 1, then D0 and D1, they may have any value. Only the selection will be that of D2. Similarly here, if D3, D2 are 0 and D1 is 1, then D0 have any value. The D1 will be selected only if D1, D2 and D3, they are having the value 0, 0 and 0. The corresponding values between the different entries and the different output variables are shown here. These values may be in a different order, depends upon the design requirements. Now K-map for the output X will have the four variables D0, D1, D2 and D3 and the output X. From the truth table, it is clear that when D3 is 1 and D0, D1 and D2, they are having any value, then the output is high. Now seeing here, D3 is 1 here, D3 is 1 here, then the output will be 1 because D0, D1 and D2 may have any value. Now the output is 1 here when D3 is 0 and D2 is 1, means D3 is 0 and D2 is 1. For this column, all the entries will be 1, 1, 1. All the other, they are 0, 0 except the first one. When all the variables are 0, 0, 0, then we are having don't care. Now the grouping, we may have the group of these 8 ones. We may have the another group of these 8 ones with the overlapping. On solving this, for this group, the output will be D3 because its value is not changing. All other values are changing from 0 to 1 or 1 to 0. So the output for this one will be D3. For this group, the value of D2 is not changing. D3 is changing from 1 to 0 and D0 and D1, they are also changing from 1 to 0 or 0 to 1. So the output will be D2. The overall output for X will be X is equal to D2 plus D3. Similarly, we can draw the K-map for the Y output. This is the group 1 for this entry. And for this one, we have to see here, D3 is 0, D2 is 0, D1 is 1, D3 is 0, D2 is 0, this column. Then D1 is 1, D1 is 1 means this column, and D0 can have any value. We are having output 1. So from the K-map, we are having the another group of 4 ones, and the simplified values will be D3, and for this one Here D2 is not changing from 0, so it will be D2 bar. Then and here D1 is not changing, so the output for this group will be D2 bar D1, and the overall output for Y will be D1 D2 bar plus D3. Similarly, we can make the K-map for V. We are having these expressions for X, Y and V, and the circuit diagram, it comes out to be this one. Only the arrangement of different basic gates. The next one is the decoder. And decoder has a number of say n input lines, has a number of say m output lines, but only one out of these is active at a given time. Means decoder is opposite to that of the encoder. The n input lines have maximum of 2 raised to power n unique output lines. M will be less than or equal to 2 raised to power n. For example, a 3-bit decoder have 8 maximum output lines and known as 3-line to 8-line decoder. The truth table of 3-line to 8-line decoder is shown here. We are having the input lines X, Y and Z. We are having the output lines D0, D1, D2, D3, D4, D5, D6 and D7. If you will see, this is just the opposite to that of the encoder. For X is 0, Y is 0, Z is 0, we are having D0 as 1 and all the other outputs are 0. For X is 0, Y is 0 and Z is 1, we are having D1 as high and all other outputs are 0. Similarly, for this entry, X is 1, Y is 1 and Z is 1, we are having the entry D7 is high and all other outputs are low. The circuit diagram is quite simple here. For the first entry, here it is X bar, Y bar, Z bar. V comes out to be for D0. Here this is D0, this is D1, this is D2, D3, D4 and D7. For D0, X complement, Y complement and Z complement at the output. Similarly, when X is 0, Y is 0 and Z is equal to 1, we are having D1 at the output. When X is 0, Y is 1, Z is 0, we are having D2 at the output. Most of the decoders include one or more enable input as shown in the figure. Enable line may be active high or active low. In this case, the enable line is active high. If enable line is active low, a bubble is placed over here. Now, in this case, when the enable input is 1, the circuit operates as a decoder. Otherwise, it will not respond to X, Y and Z inputs. The references for this discussion are from Fundamentals of Digital Circuit by A. Anand Kumar and from Digital Principles and Application by Leach, Malvino and Saha.